Harold Jeffreys was born on April 22, 1891 in Durham, England. He graduated from Durham University, in which he initially carried out research in chemistry and photography. In 1914, Jeffreys became a Fellow of St. John's College, Cambridge. At the University of Cambridge, he taught mathematics, then geophysics, and finally became the Pluminian Professor of Astronomy. He married another mathematician and physicist, Bertha Swirls, in 1940, and together they wrote the Methods of Mathematical Physics. One of his major contributions was the Bayesian approach to probability, as well as the idea that the Earth's planetary core was liquid. From 1946 to 1958, he became a lecturer at Cambridge University, in which he taught mathematics, geophysics, and astronomy. Jeffreys received multiple awards in his respective fields, such as the Gold Medal of the Royal Astronomy Society in 1937, the Royal Society's Copley Medal in 1960, and the Gold Medal of the Royal Statistical Society in 1962. In his work in astronomy, Jeffreys established that the four large outer planets are very cold and devised early models of their planetary structure. His other astronomical work includes research into the origin of the solar system and the theory of the variation of latitude. In geophysics, he investigated the thermal history of the Earth, was co-author of the standard tables of travel times for earthquake waves, and was the first to demonstrate that the Earth's core was liquid. Jeffreys was also an effective critic of the feasibility of the theory of continental drift. Harold Jeffreys' theory of probability, which was first published in 1939, played an important role in the revival of the Bayesian view of probability. The Bayesian approach is used to judge the amount of confidence researchers have in a particular result. This is the opposite of frequency probability, because frequency probability uses traditional null hypothesis that restricts the researcher to yes and no answers. Bayesian inference can be applied to a wide range of activities, including science, engineering, philosophy, medicine, sport, and law. Harold Jeffreys died on March 18, 1989.
In this video, we're going to take a look at Bayes' rule, which is arguably the most famous rule of probability theory. It's famous because it provides a model for an important process in human reasoning, namely learning from experience. Bayes' rule can tell us how we should modify the strength of our belief in a particular hypothesis after we've learned some new bit of evidence. In this video, we're just going to show how Bayes' rule follows from the general rule for conditional probabilities and look at two example calculations. Here's the general rule for conditional probability. It serves as the basic definition of conditional probability in probability theory. We can rewrite this formula by swapping out the numerator with the general formula for conjunctions. This is just a rearranged form of the general conditional probability rule, so we're really just swapping around terms here. What we have now is the simplest form of Bayes' rule, but there's a more useful formulation that is more commonly used, which we get by rewriting the denominator in terms of the total probability of B. If you don't have a clue where the expression for total probability comes from, then I'd recommend watching the previous tutorial where we derived it. But this is one of the working versions of Bayes' rule. It's one of the versions we generally use in calculations.